Okay, so in this video problem, I'm asking you to come up with a short synthesis. So, hit pause and try to come up with a series of a reaction or a series of reactions that would take you from the ethyl ester to the thioester. Okay, so first, I'm going to sort of make an assumption about what you might have tried. This looks deceptively easy. The hard part here, if you go back and think about carboxylic acid derivatives that I put up on the board that you'll find in chapter 20, they react at different rates toward nucleophiles, toward hydrolysis. Okay, so you might have thought, wow, this is really set up easily, right? There's no change in oxidation here. You don't make any other bonds here. This really is a short synthesis. And so you might have thought, okay, I'll just do this. Come up with thiophenoxide anion. Remember, pH, phenyl, is an abbreviation for this ring, a benzene ring when it's bonded to one thing, right? So we could write this molecule as that. That would be a perfectly fine way to write that. I like for beginning sort of new organic students to write out the benzene ring, write out the pi bonds in there. You can write a circle in there. You can do a lot of different things. But draw the molecule the way it actually looks. Okay, so again, the deceptively simple answer was thiophenoxide just adds in here. You say this is the equilibrium. You get a tetrahedral intermediate. And then the O minus kicks out a ethoxide, and there you go. Your other product is going to be ethoxide there. Easy. Why is this a video? Why is Jones asking me to do this? Well, the answer is this almost certainly happens. If you treat ethyl benzoate with thiophenoxide anion, then thiophenoxide, that doesn't make any sense. Phenyl sulfide anion. The sulfide anion almost certainly adds into the electrophilic carbonyl. Right? This is just something that nucleophiles do. They add into carbonyls. They often get kicked right back out. And so you probably get this, but here's the point where you got trouble. I've said O minus kicks out ethoxide. Well, just as easily, I say just as easily, O minus could kick out phenyl sulfide, and we go back to the starting material, all right? So which one, think about this from an acid-base perspective. Which one of these is a stronger base? And the answer is ethoxide by a lot. Which bond here is stronger, carbon-oxygen or carbon-sulfur? Again, the answer is carbon-oxygen. And so what happens is this doesn't go at all. Even if you flood the system with phenyl sulfide, it's not going to make ethoxide. You're just asking the reaction to go uphill too much. So phenyl sulfide will add in, and it will get kicked right back out. You're obviously not kicking out phenyl either. So that was the deceptively simple answer. I'm going to erase the deceptively simple answer that's wrong, which often happens. While I'm doing that, you can pause, and if you put this answer down, if this was your answer, hit pause and go back and think about it. If it wasn't your answer, I apologize for taking up your time. All right. Okay, so we can't do this in one step. You can't just go straight from the ethyl ester to the thioester. That's going uphill in reactivity. The ethyl ester is a more stable ester than the thioester. So what you have to do is you have to do a couple of steps. There's two ways of doing this. So option one, honestly, there's probably a lot more ways to do this. I'm reserving the answers to answers you'll find in Klein's textbook. Okay, so option one is both options require hydrolysis. Okay. I'll differentiate the options in a minute. So both of these are going to require hydrolysis. So we need to get to the carboxylic acid. And there's two ways of doing that even. So we've got two options for what we're going to do with the benzoic acid, and we've got two ways of getting to the benzoic acid. So one is H3O plus H2O and just reflux this. So reflux ethyl benzoate and aqueous acid, that gets you right there. The second option for hydrolysis is first, say lithium hydroxide, H2O, and you could reflux this or not. Hydroxide, in my experience anyway, ethyl esters hydrolyze just really nicely in aqueous base. Remember though, this could be lithium or sodium or potassium. It makes a little bit of difference in terms of solubility. If you want to use an organic co-solvent like THF or something, lithium hydroxide is usually better. So this is going to give, OH minus is going to hydrolyze the ester to a carboxylate. And so we're going to end up here. And what we want is benzoic acid. So how do you turn a carboxylate into a carboxylic acid? You can hit pause if you want to think about it. So I want to turn the red carboxylate into the blue acid. How do I do that? I'm trying to make you think about this. Suck up valuable YouTube. I mean, there could be cats here or something. Okay, the way you do this, second step then is going to be something like HCl. You need a strong acid, right? So if I've got HCl here, that takes me up there just fine. Okay, I'm going to erase the red stuff down here. Okay, once you get to the benzoic acid, now you've got a couple of different things you can do with that. Option one, first step, thionyl chloride. Second step, we need to add a phenyl sulfide, so thiophenol. So it looks like phenol, there's just an S instead of an O. And then you need some sort of base, right? So now the base will take that H, so step one gives us the acid chloride. Phenyl sulfide adds to the acid chloride. And now you're probably thinking, well, wait a minute, you just said that the sulfur adds into the carbonyl and it gets kicked back out. But remember, that was with ethoxide being the leaving group. From here, the leaving group is chloride. Chloride's a much better leaving group. Chloride minus, right, I erased it. Chloride minus is the conjugate base of a really strong acid, so it's a really weak base. And so in fact, that's what happens here. O minus gets kicked out, or O minus kicks out the chloride, and we get the desired product. Right? So option one with the benzoic acid is to use thionyl chloride to make the acid chloride, right? Go all the way back up to the top of the carboxylic acid reactivity with nucleophiles, and then treat with thiophenol. There you go. The second option is a little more straightforward, and I'm not going to go through the mechanism. It's in the book. Should be in your class notes. Might be in your class notes. I can't remember. It's just to use this coupling reagent, dicyclohexyl carbodiamide (DCC), and thiophenol. Okay, not the thiophenoxide. The reaction itself needs that H to be there. And this directly in one step gives you the product. Okay, so why wouldn't I use option two? It's one step. Well, a couple of reasons. One, DCC turns into DCU. That is not the DC universe. It's dicyclohexyl carbodiamide. No, that is dicyclohexyl urea. Come to think of it, that's kind of like the DC universe. It's really sticky. It's hard to get rid of. and it just hangs around when you don't want it to. So, okay, that was unfair. Anyway, the DCU is a hard byproduct to get rid of. You can use something other than cyclohexyl here, which makes it easier, but then that reagent gets more expensive. And expense, again, is sort of the reason. DCC is often, it's a hygroscopic reagent, it goes bad. Slightly, well, I don't know if it's more expensive than thionyl chloride, probably not. Thionyl chloride, the byproducts are sulfur dioxide and HCl. So as long as you don't mind polluting the atmosphere a little bit, it's easier to get rid of those. So purification of the final product here might be easier than in the bottom step. But honestly, this is sort of, it's going to depend. You're not going to make this compound probably. You're probably going to buy that. I bet that's commercial. So it depends on what you're making, which one of these reactions would be best. And again, I've said this in class. I've said option 1 and 2. For a lot of transformations, there are hundreds, if not thousands, of ways to do the reaction, and this is one of them. All right, going from a carboxylic acid to any kind of carboxylic acid derivative. I've shown you 2 reagents. There are let's say hundreds. There are hundreds of reagents that do this. If you become a professional chemist, you should definitely search the literature for this. All those reagents are kind of tailored to a specific application where they excel at. You often, the important thing to learn here is just the concept of going from the carboxylic acid derivative to another carboxylic, or going from a carboxylic acid to another carboxylic acid derivative. And that's often the easiest way to go from one derivative to another, right? So to go from an ester to a thioester, ester to an amide, ester to an anhydride, whatever, you're almost always going to hydrolyze, go to the acid, and then go from the acid to whatever you need to go to. Short, eh? How long was that video? Good Lord, 13 minutes for that. Sorry.